So the problem says that due to slipping, points A and B on the rim of the disk have the velocities shown. Determine the velocities of center points C, D, and E. So we are given that point A is having a velocity of 5 feet per second and point B is having a velocity of 10 feet per second. And we are required to find the velocity of point D and E on the rim of this disk. So now, as we are given that point A is moving with 5 feet per second and point B is moving to the left with 10 feet per second. So the velocity of B to the left is greater than the velocity of A to the right. So this means that the whole disk is going to have the angular velocity in this direction, that is in the counterclockwise direction. So we can say that the disk is rotating in the counterclockwise direction. So it is having the omega in this direction. But since this disk is slipping, velocity of point A is less than velocity of point B. So the disk is not revolving about this point C. Like the instantaneous center of point B and point A is not aligned with the center of the disk, right? So the instantaneous center is going to be at some other point. So first of all, we're going to find the instantaneous center of zero velocity for point A and B, and then that using that instantaneous center, we'll be able to find the velocity of point D and E. So this will be the velocity of A of magnitude 5 feet per second. This is V of A, let's say. Let me write this is VA equals to 5 feet per second. And at B, we will have VB, and VB is 10 feet per second. So the length of the vector VB must be twice the vector of VA, right? So this is VB. So VB is 10 feet per second. In order to find the accurate instantaneous center, we need to draw the length of VB approximately equal to twice the length of VA, since VB magnitude is twice the magnitude of VA. So now in order to find the instantaneous center, we need to join the heads of both of these velocities and we need to join the tails of both of these velocities. So I will join the head of VB with VA and we will join the tails of VB and VA like this. So the instantaneous center of zero velocity is at the intersection point of these two blue lines. So so here we have the instantaneous center of zero velocity. So this intersection point is instantaneous center of zero velocity. So now let's assume that this distance is, let's say, x. The distance between the instantaneous center and point B is x. So let's say that this distance is, let's say, x. So if we know the diameter of the disk, which is 0. The radius is 0.8, so the diameter is 1.6. Then, so if this is x, then this will be the diameter minus this x. So this distance will be 1.6 minus x. So 1.6 is the diameter, so the radius is 0.8. So we can say that this distance 1.6 minus x. So now using the properties of a similar triangle, since this triangle and this triangle, they are similar triangles, right? So we can say that this angle is the same, this is the 90 degree, this is 90 degree, and this angle and this angle, they will remain the same. So we can say that this x divided by this, the ratios of the corresponding sides of the similar triangles are always equal. So we can say that x divided by 10 is equal to this, which is 1.6 minus x divided by 5. So we can say 1.6 minus x divided by 5. So now we can say that if we cross multiply, so this will be 5x into 10 into 1 minus 6, 1.6 minus x. So this is 5x equals to 1.6 into 10 is 16. minus x, minus 10x, sorry. And if I bring this 10x to the other side, so we will have 5x plus 10x equals to 16, and 15x is equal to 16. And we can say that x is equal to 16 divided by 15. So 16 divided by 15, this gives us 1.067. So x is equal to 1.0667 feet, right? Since this diameter is in feet, so this will be in feet as well. So x is 1.667 feet. So now we know this x, the distance of point B from the instantaneous center, and once we know this x, we know the distance of point A from the instantaneous center. So now once we know this x, we can find the velocity of point C. So the velocity of point C is going to be towards the left, since the disk is revolving in the counterclockwise direction. So the velocity of point C will be due to that angular velocity, right, about this instantaneous center. So the velocity of point C is going to be like this, right? So we are going to have VC. So this will be VC. So the velocity of the center of point, and we can say, we can always use that relationship V equals to R omega once we find the instantaneous center. So we can say that VC is equal to R of C, I of C into omega. So first of all, we need to find omega. So now once we find this, we can find omega. How to find omega? Again, we can use this same relationship for VB as well. So for VB, we can say that we can write that VB will be equal to R of B instantaneous center times omega. And R of B instantaneous center will be a vector from instantaneous center to that point B. So this will be R of B instantaneous center, a vector which is drawn from the instantaneous center to the point B, which is where the tail of VB is, right? So that will be the position vector for the velocity of B relative to instantaneous center. So this vector is having a magnitude of x. So this, we can say that this is 16 divided by 15 feet. This is 16 divided by 15 feet, or 1.0667, multiplied by omega. Omega is not known, which is the angular velocity of the disk, and VB is known, which is 10, right? So we can say, from this, we can say that 10 into 15 divided by 16 is the omega. So we can say that 10 multiplied by 15 divided by 16. So this gives us omega equals to 9.375 radian per second. And this angular velocity is in the counterclockwise direction. So now to find VC, we have omega, so we need to find the length of this. We need to find the magnitude of the position vector from the instantaneous center to point C. So R of C, I of C will be this vector, right? So we will have this vector. So this is R of C instantaneous center. So now we can find this. If we know this, if we know this length, so this is the radius. So if we subtract the radius, we will get this. So R of C, we can say that VC is equal to R of C, I of C is the x minus the radius, which is 0.8. The radius of the disk is 0.8. So this distance is 0.8. And this whole distance is x. So x minus 0.8 will be R of C, I of C times omega. So VC is equal to, now x is 16 divided by 15 feet minus 0.8 into omega. Omega is 9.375. So we will have VC, the velocity of the center of the disk, which is, we can say 16 divided by 15 minus 0.8 multiplied by 9.375. So this gives us 2.5. So the velocity of point C is 2.5 feet per second, and this is towards the left, remember. Now to find the velocity of point D, we need to join the instantaneous center with that point D. So this will be, and similarly we can join the center with point D as well. So now we are having this triangle, right? And the velocity of point D is again due to the angular velocity of the disk about the instantaneous center, and the velocity of point D must be perpendicular to this line, right? So the velocity of D is acting like this. It is not tangent to the circumference of the disk. That velocity of point D will be perpendicular to this line which joins point D and instantaneous center, since uh, if the center of rotation was point C, then the velocity of D must be tangent to the circumference of the circle. But now, since the instantaneous center doesn't coincide with point C, then the velocity of D will be tangent to this line which is joining the point D and instantaneous center. So the velocity of D will be like this, right? So we can say that the velocity of point D is like this, and it is not tangent to the circumference of the circle. It is making 90-degree with that line which is joining point D and instantaneous center. Now we know that this length is 0.8, which is the radius. So we can say that this is 0.8 feet. We know this length. This length is x minus 0.8, right? So this length is x minus 0.8. X minus 0.8, which is equal to x is 16 divided by 15 minus 0.8. So this is 4 divided by 15. So 4 divided by 15 feet. Or we can say that this is 0.267 feet. So now we know this length, and here we are given that this point D is the line which join point C and D is making 45-degree angle. So this angle is 45 degree. So this angle is given as well. This is 45 degrees. So if this angle is 45 degrees, so then this angle is 45 as well. And this is 90. So 90 plus 45. So 90 plus 45 is 135. Or we can say that if this angle is 45, then this angle will be 180 minus 45. So 180 minus 45 is 135. So this angle is 135. So this angle is 135. Let's say this is 135 degrees. So now our main focus is on this triangle. We know that this length is 0.8 feet. This is 4 divided by 15 feet, and this included angle is 135 feet. So now using the law of cosines, we can find the magnitude of R of D relative to instantaneous center. Since we want to find VD, so VD is equal to R of D instantaneous center times omega. We know omega, we need to find R of D, the magnitude of the position vector from the instantaneous center to that point D. So this will be R of D instantaneous center. So we need to find this length, which will be the magnitude of the position vector from the instantaneous center to that point D. So now using law of cosines to that triangle, we can say that this DC, we can say that this DC square will be equal to this square plus the square of this. So let's apply the law of cosine. So we can say that DC square is equal to CD square plus C instantaneous center square minus 2 into CD into C instantaneous center cosine of the included angle. So the included angle is 135 degrees. And if you want to find the length of DC, we need to take the square root. So this will be equal to, DC will be equal to CD square, which is the radius. So 0.8 square plus this is C instantaneous center. This is this 4 divided by 15 feet. So 4 divided by 15 square minus 2 into 0.8 into 4 divided by 15 cos of 135, and then taking the square root. So this will give us So now this DC comes out to be equals to 1.006 feet. And now once we know this VD, sorry, the length of this distance between point D and instantaneous center, we know the magnitude of the position vector from the instantaneous center to point D. So we can use this relationship. So we can say that VD is equal to this 1.006 into omega. So omega is 9.375. So we can say that this answer multiplied by 9.375. So this gives us 9.435 VD. So VD is 9.435 feet per second. Now we have determined the magnitude of the VD, but now the next step is to find the angle of this VD, since in order to completely define the velocity of point D, we need to have the magnitude of that velocity and we need to have the direction of the velocity. So we need to find the angle of this VD either with the horizontal or with the vertical, right? So if we somehow find this angle, let's say if we find this angle, then we will be able to find the angle of this VD with the vertical, right? So if we find this angle, let's say this angle is alpha, then if I draw a vertical line here, so then this vertical line is perpendicular with this line, and this VD is perpendicular with this line. So if the angle between these two lines is known, then the angle between this and this is known as well. So if this angle is alpha, then this angle is alpha as well. So let's find this angle alpha. So to find this angle alpha, we need to find this angle, right? So we can find this angle by using the law of sines. So if we apply the law of sines, so we can say this angle is, let's say, angle beta. This angle is angle beta, let's say. So let me draw that triangle here. So we are having the triangle like this. This is that point D, this is point C, and this is the instantaneous center. This CD is 0.8 feet. This angle is 135, and this length is 4 divided by 15 feet. And we know that the distance between the instantaneous center and point D is this 1.006. So this 1.006 feet. We want to find this angle alpha. So for that, we need to find this angle beta. So now the angle beta will be, using the law of sines, we can say that sine of beta divided by the opposite side, the magnitude of the opposite side is 0.8 divided by sine of 135 divided by the magnitude of the opposite side. So from this we can say that beta is equal to, or we can say sine of beta is equal to 0.8 sine of 135 divided by 1.006, and if we take sine inverse, we will be able to find beta. So sine inverse 0.8 sine of 135 divided by 1.006. So beta comes out to be 34.216 degrees. So now if once we find this beta, is we know that this angle is 90 degrees, then alpha will be equal to 90 minus beta. So we can say that alpha is equal to 90 minus beta. So we can say that 90 minus this answer is 55. So angle alpha is 55.784 degrees. And now since the velocity of point D is perpendicular to this line, right? So let me draw that velocity of point D. So this is that VD. This is perpendicular to this, and this is that horizontal line. If I draw a vertical line here, so as we know that the angle between this line and this line is angle alpha. Now if this VD is perpendicular to this line and this vertical line is perpendicular to this line, then this angle and this angle, they are equal. So we can say that this angle is angle alpha as well. So now the magnitude of the velocity of point D is this 9.435, and it is making, we can say that VD is magnitude is 9.435 feet per second, and it is making 55.784 with the vertical. So we can say that this is that angle, which is 55.784 degrees. And let's say if the problem statement asks us that to find the angle with the horizontal, then this angle will be 90 minus alpha. So 90 minus alpha, so 90 minus 55.784. So with the horizontal, it is making 34.22 degree angle. So VD is having magnitude of 9.435, and it is making 55.784 degrees with the vertical, or it is making 34.216 degree angle with the horizontal. Now the problem also says that this second problem also says everything remains the same. This says that also find the velocity of point E as well. So now again, considering the same instantaneous center, we have to find the velocity of point E. So let me erase all these. So now for point E, we need to join that point E with the instantaneous center. So let's join this point E with the instantaneous center. So we will have this. Now we are having this triangle, right angle triangle. Now we can say that the velocity of E will be equal to R of E instantaneous center times omega. So R of E instantaneous center will be a position vector from the instantaneous center to that point E. So we need to find the magnitude of that position vector from instantaneous center to point E. So we need to find this length. So now we know this length, this is 0.8, this is 4 divided by 15, x minus 0.8, this is x minus 0.8. So let's draw that right angle triangle here. So this is point C, this is point E, this is instantaneous center, this is x minus 0.8, which is 4 divided by 15. You know x is 16 divided by 15 feet. This is x is, we have determined this here, right? So this is 4 divided by 15 feet, and we want to find this length. We know this as well. This is 0.8. This is 0.8. So now this is a right angle triangle. We can find this is the hypotenuse. This is the hypotenuse, which will be the length of R of E instantaneous center. So we can find it using Pythagoras theorem. So that will enable us to find the velocity of point E. So VE is equal to R of E is using Pythagoras theorem. So that will be 0.8 square plus 4 divided by 15 square under the square root, multiply by omega. Omega is 9.375 radian per second. So VE is 4 divided by 15 square multiply by answer multiply by 9.375. So this gives us VE magnitude 7.906 feet per second. This is VE. And again, since the instantaneous center and the center of the disk doesn't coincide, this point E is revolving about the instantaneous center due to that angular velocity of the disk. So the velocity of point E will be making 90 degree with this line. It's not going to be tangent to the circumference of the circle. It's in the direction of VE is like this, and it is making 90 degree with this line. So we have to find the angle of this VE with the horizontal or with the vertical, right? So in order to find in order to completely describe the magnitude and direction of the velocity of point E. So VE is acting like this. It is making 90 degree. So if we find this angle, let's say if this angle is, let's say now angle theta. So if we find this angle theta, so then we will be able to find the angle of VE with the horizontal, since this line is horizontal. So we will be able to find this angle. So let's find this angle theta. We can find this angle theta using this triangle. So we can say that tan theta will be equal to perpendicular. Now the perpendicular is 4 divided by 15 divided by the base. And if we take tan inverse, we will be able to find theta. So tan inverse 4 divided by 15 divided by 0.8. So this gives us theta equals to 18.435 degrees. So if this is 90 degree, then this VE is making 90 plus theta with the horizontal in the clockwise direction. So we can say that VE is making this answer plus 90 degree, 108.434. So VE, how much is the angle? Which is 108.43. So VE is having a magnitude of 7.906 feet per second, and it is making 108.43 degrees with the horizontal in the clockwise direction. You guys can draw the direction like this as well. So in order to not confuse yourself, draw the velocity like this and show this angle, which is 108.43 degrees. So I think all this discussion will help you in your learning. I think this is the difficult problem and a little bit confusing. I hope all this discussion will help you in your learning. Please let me know in the comments if all these videos helps in your understanding and learning of engineering dynamics chapter 16, and do subscribe Engineers Academy for the solution of such more problems from engineering dynamics by Hibbeler.